I'm going to start with a small demo of Heliotrope and how to get the sun information into your model. So starting out, I have our definition from last week, and we're going to use some of this later and integrate it with our new analysis. But for now, I'm just going to hide everything that was visualized just to give you a quick demo of how Heliotrope works. So Heliotrope has a few tools to work with sun, and also works, it has some utilities to compose day and time. This is how you tell Heliotrope which time of the year or which time during the day you want to do your analysis. So we're going to go down to this Julian Day tab and go to JDay compose. And this compose node will allow us to compose a day value. So you can see here there's a definition of a specific time and a specific day. And you can compose those by specifying actually your year, month, day, hour, minute, second. And we want to use this node because we actually want to control which times we're analyzing. So to start out, I'm going to specify the year with a panel. I don't want this to change, so it can be a constant. So I'm going to make a new panel, put in 2014, hit OK, and just plug that into the year. Now if you hover over this, you can see that the year changed to 2014. And all these will come preloaded with presets. Okay, the next thing I'm going to do is make a series of sliders so we can specify the month, day, hour, minute, second as variables. So I'm going to make a slider defaulted to 10. I want integers, so just do 10. Plug into the month. And this, I want to change the minimum maximum values to the minimum maximum months, just so I don't go beyond what it's expecting. So I'm going to set the minimum to 1 and the maximum to 12 of the month slider. And if you hover over month, it'll actually tell you the range in those square brackets of what it's expecting. Okay, I'm going to copy that for day. And here I'm going to make the range from 1 to 31, so that's the maximum days in any month. I'm going to copy it for hour, and hour is expecting 0 to 23. So I'm going to change those values. And for the minute, I'm going to change it to 0 to 59. Okay, so now I have my setup to compose any time and day and hour, minute of any year. I'm going to keep seconds blank because it doesn't really matter. We don't need to go into that level of precision. Okay, so once we have our day composed, I'm going to create solar setup, basically. And Heliotrope will take whichever day I specified and create kind of a solar arc, which shows the path of the sun on that given day. The tool for that is in sun and solar arc. So if you drag that out, you can see another series of inputs. The first input is the J day. So this is the day that we want the solar arc composed for, and we can just drag that in from our compose node. The next series of inputs will specify your geographic location. So you can specify this yourself for wherever you are in the world, but a really useful tool that's in Helio is the Rhino get tool, which will actually get information from Rhino about your location. Okay, so we're going to use this Rhino get command. Again, that's under the Rhino tab. And we're going to use this to get our latitude and longitude. So by default, if you drag this in, you'll notice that there's nothing in lat and long. And that's because we actually haven't set our location in Rhino yet. So based on what we covered last week, so in order to get this to work, we actually have to specify the location in the sun dialog. Go back to Rhino, type in sun, and here we want to turn our sun on, and in this dialog box specify our location. So we can click here. So it'll default to New York, and once we have that set, we can exit out. Now you'll notice that in the Rhino get node, there's the latitude and longitude right there, and this north vector will respond to whatever we set in our environment as well. So since that's 0 degrees in our model, it'll default to the y vector, which is what I want. So once we have those values coming in, we just plug them in directly, lat to lat, long to long, and the north vector. And then an additional thing we can do, which isn't super crucial, but is nice if you're working with actual times, is connect this offset parameter coming from Rhino into the offset and compose. And this will basically tell it how many time zones away from the base UTC standard. And this will help you transfer your time from Rhino into Helio. Okay, so once we have that, we have our solar arc built. Chances are you won't be able to see it because it'll be really small. So the next thing we want to do is we want to specify these different scale properties to get our solar arc so we can see it in the viewport. The first one is the scale factor for sizing the arc. I'm just going to make a slider, and then I just want to scale this down until I see the arc. All right, and the next one is the scale factor for the sun. Make another slider. And here you can see the sun. So all this geometry is composed of just simple Rhino geometry. So an arc for the path, a sphere for the sun, but it helps you really visualize what's going on. So the next parameter is the offset. And this is a little bit strange about Heliotrope, but it won't use the actual time we composed to generate the sun. It'll use some fraction over the course of the day. So it calculates the sunrise to sunset, and then this offset actually tells it where along that day you want the sun to be. Okay, so here we'll just make a slider, type in 1.0. This will give us a slider from 0 to 1, which will control the location of our sun. Put that into offset. You can see now as we scrub through, we can get different locations of the sun. Also, we can change the month, and it'll change our arc, and we can change the day. Okay, so for now, all we've made is a solar arc. It's a good tool for visualization, but what's really cool about it is that we can actually get pieces of geometry out of this. We can get the arc itself, which is fine. We can get the sun ball, but there's this third piece, which is the vector, and this becomes really useful because it'll give us a vector from the origin to the sun, and we can start to use that vector to compose our own analysis tools. Okay, so the first thing I'll do is I'll try to visualize this vector with a line just so you can see what's going on. So I'm gonna make my usual line SDL node, and I'll just create a line following that vector. So as a start, I'll just make a point, go to set one point, type in 0, so this will be my origin. For direction, I'll plug in the vector that's coming out of my solar arc, and then I'll make a slider to specify the length of that line. So you see now I have this vector coming from the origin, and this is responding dynamically to the position of my sun. All right, so that's the basic setup we'll use for a heliotrope to compose our own sun study tool. And you can go through the examples that are provided with the plugin or any of these other commands. Heliotrope does a number of other simple things, like it does shadow projections, but I'll leave that to you to explore.